It's magnificent to see you again, scientists! Today, we're going on a journey through space to learn about something truly extraordinary. Eclipses. Does anybody know what an eclipse is? An eclipse is when one celestial body, like a planet, moon, or star, moves into the shadow of another celestial body. And today, we're going to delve deeper into the two main types of eclipses, solar and lunar. But first, let's understand what causes these amazing phenomena. Imagine this. We have the Earth, the Moon, and the Sun all lined up in space. During a solar eclipse, the Moon moves between the Earth and the Sun, blocking out the Sun's light for a brief moment. And during a lunar eclipse, the Earth moves between the Sun and the Moon, casting a shadow on the Moon. Astronomers are able to predict eclipses because the Earth and the Moon have very predictable orbits. Now, I know what you're thinking. Why don't we have eclipses all the time if the Earth, Moon, and Sun are always moving? An excellent question indeed. You see, the orbits of the Earth and the Moon are not perfectly aligned. The Moon's orbit is usually tilted a few degrees north or south in relation to the Earth, which is why we don't have eclipses happening every month. But when things line up just right, boom! We've got ourselves an eclipse, scientists! Now, by pure cosmic happenstance, the Sun is 400 times wider than the Moon, but it's also 400 times further away, giving the illusion that the two are the same size in our sky. During a solar eclipse, the Moon eclipses the Sun and casts two types of shadows on Earth. A smaller, darker shadow called the Umbra shadow, and a larger but less intense shadow known as the Penumbra shadow. The same two shadows are cast during a lunar eclipse as well, but instead of a shadow being cast on Earth, the shadow is cast on the Moon instead. Everybody got that? Sensational! On we go! There are three types of solar eclipses: total, partial, and annular. A total solar eclipse occurs when the Moon completely covers the Sun, casting a shadow on certain parts of the Earth. It can only be seen if you're standing within the Umbra shadow. The imaginary line created by this shadow as it races across Earth is called the Path of Totality. During a total solar eclipse, the sky can become as dark as night and temperatures can drop as much as 20 degrees. A partial solar eclipse, however, happens when only a part of the Moon passes in front of the Sun. You can see a partial eclipse if you're standing outside the Path of Totality, but within the Penumbra shadow. And an annular solar eclipse occurs when the Moon passes directly in front of the Sun, but unlike a total eclipse, the Moon appears too small to completely cover the Sun, leaving a ring of sunlight visible around the edges. You see, the Moon's orbit is elliptical, so sometimes it's closer to Earth, and other times it's further away. Lunar eclipses, on the other hand, are equally fascinating. Just like solar eclipses, there are three different types: total, partial, and penumbral. During a total lunar eclipse, the Moon falls within the Earth's Umbra shadow, giving it a reddish hue, often called a blood moon. A partial lunar eclipse occurs when only part of the Moon enters the Earth's shadow. During a partial lunar eclipse, the Earth's shadow will appear very dark on the side of the Moon that's facing the Earth. And a penumbral lunar eclipse happens when the Moon passes through the faint outer penumbral shadow of the Earth, resulting in a subtle darkening of the Moon. This event is so subtle that most people don't even know that it's happening. Astonishing, right? Let's see if you're paying attention, scientists. What is a total solar eclipse? Is it A, when the Moon completely covers the Sun? B, when the Sun completely covers the Earth? C, when the Moon partially covers Mars? Or D, when the Earth completely orbits the Sun? Did you answer A, when the Moon completely covers the Sun? That's throwing some shade, scientists. You're right. Let's press on. Eclipses are truly remarkable cosmic events that have captivated humans for centuries. They remind us of the beauty and wonder of our universe. I do hope you enjoyed our adventure through the interstellar world of eclipses today, scientists. Until we see each other again, don't forget to experiment, record, and analyze with Empirical's evidence.